Hello friends, I am Sirisha. Welcome to Series Molecular World. Today we are going to discuss about the second chapter of 10th class, that is acids, bases and salts. Okay? So first of all, see, like day by day, every day we are using many things in our life, like edible things or the compounds. Even in periodic table we are discussing 118 elements are there. In those all 118 elements, how we are making alphabets by using to make words. The same thing, the same way as usual, like elements when you are mixing together, we will get some compounds. Like we have discussed about the physical classification of matter, chemical classification of matter, their mixture and so on, again compounds. Those compounds, how the compounds are making, how those compounds are useful to our mankind. That is what we are going to discuss. Okay. So how can you say whether a substance is acid or a base or a salt? We are using like some compounds we are taking, when you are tasting it, it is becoming little sour in taste. Some substances when you are touching with our tongue, you will feel bitter in taste, right? No? So like those all the compounds, how can you prefer whether a substance is based on sour in taste or based on bitter in taste? How can you classify the elements? That is what we are going to discuss in the lesson. This lesson we are calling acids, bases and salts. Okay. So already I wrote something here. See, acid. Acid in the sense, acid, the word acid came from the acidus, it's a Latin word, and that means sour in taste. Sour in taste, okay? And sour in taste, when these acids, when you are adding a water to these acids, they releases the H plus ions. So what is meant by ion? Ion is nothing but a charged particle. So like, for example, when you are taking plus or minus, you take plus or minus. Plus ions we are taking, we are giving explanation as a positive ion and negative ion. Both the plus and minus are combining each other by the electrolytes. They are combining each other to form a compound. Especially we can say these all are the ionic compounds or maybe covalent compounds. Okay. So when these acids are released, adding with water, we are getting the release of H plus ions. So presence of this H plus ions. We can say, for example, main example here we are giving hydrochloric acid, sulfuric acid, nitric acid. Okay. So you take here, when you are considering hydrochloric acid, this is coming as a H plus. Here plus is there. And even here minus charge. Okay. So presence of this H plus ion, we are considering these are acids. Okay. In our daily life, we are seeing many acids. We are giving the examples as carbonic acid, phosphoric acid, sulfuric acid, and sulfurous acid, nitrous acid, even citric acid, many things. Okay. So that we will discuss in our next classes. About the how much strong of the acid and how much weak of the base, that we will discuss. Okay. So now the next one, here we are coming to the next one. This is called base. Base is nothing but bases are bitter in taste. Like for example, when you are bathing, you are touching without without knowing that soap will go inside. How can you feel? You are feeling so bitter in taste, right? So the same bitter, not only the soap, many things, even bitter gourd. Maybe you don't like to eat bitter gourd, but it's very good actually. Basic substances are present in the bitter gourd called as a quinines. Okay. So like those type of the things we are using, even those are also edible we are using. Okay. So bitter in taste. And these bases will release the OH minus ions. OH minus ions. We are calling OH minus ions as hydroxyl ions. Okay. Hydroxyl ions. And these are the negatively charged particles. Those particles are combining with the positively charged particles to make a compound. Okay. So we can say these acids are the inorganic compounds. Even the bases also we can say it as the inorganic compounds. Okay. So here you take, I wrote here as a normal sodium hydroxide. Okay. So NaOH you take. So here OH is there. And again MgOH twice of MgOH. Magnesium hydroxide. So here also we can say OH. Calcium hydroxide, OH. And even you take ammonium hydroxide, NH4OH, OH. Okay. So presence of OH minus ions, it indicates it is a base. Okay. Presence of hydroxyl ions, we are calling those compounds as a bases. Okay. Now, how can you find out whether these substances are acidic or basic? Is it possible to taste all the substances? No, right? Is it possible to touch all the things? No, not possible. Okay. So to find out that, what we are using a specific type of substances. Here we are calling as a indicators. Here we are calling as a indicators. These are the indicators are the chemical substances or a dye which can be represents here whether a substance is an acid or a base. We are using these substances as to find whether a substance is a chemical acid or a base. Okay. So here in these indicators we have many types of indicators. Like some things will be differently. Like for example, see even surf excel ad they are giving like suddenly some curries is fell down on your dress. What will happen when you are rubbing with the soap? It will turn the color, right? No. So how the color change? Like those we are calling as a specific type of indicators, and these indicators are based on the color change and then odor or smell we can say. And the color changes, we have the two types of indicators called natural indicators and synthetic indicators. And these natural indicators like litmus, we know the litmus reagent belongs to a type of plant. It belongs to a type of plant. We are calling that as lichen. Litmus reagent we are calling a type of plant called lichen, and these are belongs to Thallophyta. These are belongs to a Thallophyta family of plant. And then this litmus lichen plant, they are taking the leaves of that and then they are putting in the hot water. It comes as a purple in color solution. Purple in color, that we will discuss. Okay. Litmus, and then turmeric reagent, the normal thing, turmeric paste we are applying, and then China rose, hibiscus flower. I think we all know about hibiscus flower. The same thing we are using here as an indicator. And then red cabbage, it's a vegetable. Okay. So like these all are the things, natural products, like plants only, all these things. Okay. So we are calling these substances are called natural indicators. And then another type of indicators. This is the word synthetic. Synthetic in the sense these indicators we are making in the laboratory. Laboratory means methyl orange and phenolphthalein indicators. And some indicators will give the different smell when you are observing. For example, when you are cutting an onion in your house, when your mother is cooking sometimes, she is frying or cutting the onion, what will happen? You will feel the smell, right? Full house you are feeling, oh, onion is cutting, and even you will get some tears in your eyes. That is also because of presence of acidic substances present in the onion. Okay. So these onion extracts we are taking here. Onion extract. So how? Onion extract, vanilla extract, and even clove oil. Cloves you are using, no? Whenever you are having a teeth pain or like that, you are keeping inside the mouth and sleeping time. Those like that you are keeping, no? That we are calling. Okay. So these indicators are especially we are calling olfactory indicators. How can you say? In your nose you have a nerve called as olfactory nerve. That is only the importance of the smell. You can sense your smell. You can feel your smell. Okay. So the because of olfactory nerves, that is why we are calling detection of smell. Okay. So that is why we are calling these are olfactory indicators. Okay. So how we are finding by using those indicators whether a substance is, for example, if they have given you 2 test tubes, okay, you don't know what type of substance is that. They have given like liquid substances they have given. How can you find out that? By using a litmus reagent we are finding. Litmus reagent we can get in the form of solution or in the form of paper also. Usually litmus reagent original color is purple in color. When you are dipping in the acidic medium, it will be in the red, it gives the red color. So red litmus, see purple in color this one, when you are dipping in this one, it will convert into red color. See here, one shortcut, like acid, D is there, no, acid and red, D, acid, red, basic, blue. So B. You can think like that, you can remember like that. basic blue. Okay. So red litmus reagent, original color is a purple color, and this is available in the form of solution or in the form of strips also. When you are dipping in the acidic medium, the purple color of the litmus reagent will turn to the red color. When you are dipping with the basic medium, that will turn into blue color. Okay. Next, the natural indicator. Another one, we are taking this one, turmeric. Like how you will do? Take a turmeric powder in a bowl, mix it into a paste with by using water. You mix it in made it like a paste and apply it on a paper. Okay. You keep it for dry that paper. Afterwards, you apply the acidic solution. There, for example, lemon. We have citric acid and all, no? So you apply that one. Normal acidic medium, the color as usual will be yellow color. There is no change of that. But when it is coming, just now I gave you one example, no, surf excel add the same thing. When you are coming, this will gives the reddish brown color. This will gives the reddish brown color. Okay. So the third one we are going to one is the hibiscus reagent. This one how you will make China rose indicator? Take a petals of hibiscus flower, put it in the hot water for some time. Okay, like 2 to 3 minutes you put it in the hot water. Because of China rose petals, the color is there, no pink color. The color will come to the water, and then that we are calling as a China rose indicator, or also called Budhal indicator. Budhal. We can also call China rose indicator as Budhal. Okay. So Budhal reagent. And then this Budhal reagent will give the light pink color. Normal color, original color is in light pink. And when it is in the acidic medium, when we are adding to the acid, it will give the dark pink color. And when you are giving in the basic medium, it gives the green color. Next, another natural indicator. We are using a red cabbage indicator. Red cabbage is available in the markets. You can get the red cabbage and you are putting in the hot water. The solution, water color will changes to the red color. Then the red cabbage indicator, original color is red in color, and then it is acidic medium, it gives as usual red color only, there is no change of color. And in case of basic medium like a sodium hydroxide, magnesium hydroxide or any other things, it is giving the green in color. Okay, it is giving the green in color. And the next one, hydrangea, it is a type of flower. Hydrangea, it's also a type of flower. Usually this flower will be blue in color. This flower will be blue in color, and when you are giving with the acidic medium, the color will be in the blue color only. And when you are giving to the basic medium, the blue color will changes to the pink to purple. Means lightly, specifically we can see like these hydrangea flowers in the near to the like Mussoorie, means Uttarakhand, Jammu and Kashmir, those places. Like if soil is pure acidic, then that will be in the blue color form. Blue color flowers will give. If soil is complete pure basic soil, then it will give the pink color. So this hydrangea depends completely on the type of soil, whether the soil is acidic or basic. We can able to explain like that. And then the 6th and 7th here I wrote here, methyl orange. Methyl orange, just now here also I mentioned you methyl orange. These are the synthetic indicators. Methyl orange will be like dark orange in color. That is Fanta orange. Did you all know? I think Fanta orange color. Okay, so that will be in the orange color. And then when you are dipping in acidic medium, when you are adding acidic medium to that methyl orange, it gives the red color. And then in the basic medium, when you are adding with any basic substance, it converts into the yellow color. Okay, yellow. This yellow very nice color actually, like lemon yellow it will come. Okay. Next, phenolphthalein indicator. Phenolphthalein, usually the indicator is a colorless. When you are adding to the acidic medium, there is no change of the color. When you are adding to the basic medium, it turns into pink color. It turns into pink color. Next, here a small word I wrote here, petunia. Petunia, these are also a type of flower. Petunia, this is normally the flower is nothing, colorless only. When you are dipping in the acidic medium, that petunia petals will give the reddish purple color, and in basic medium when you are dipping the petals, it will give the purple in color. And like this, even we have another one here, geranium. Geranium, these flowers are also the same thing, they will give the same color. When you are dipping with the basic medium, it turns into violet color. Okay, So these are the explanations normal, like how can you find out? Based on these indicators, we can find out the acids and bases. Yes, no? So I hope everyone understood about this. Next we have another type of classification, that is called salt. How can you say whether a substance is a salt? Like now, how can you say whether a substance is a salt? Salt. Okay. Salt. Usually what we'll say, we are saying salt means by saying the salt. What you will think about that? Salt means common salt, common table salt. How can you say common table salt? What is the common formula we are using here? Sodium chloride. Sodium chloride. We all know sodium is a metal. Metals are electropositive. By removing one electron, they are becoming as a positive ion. And chlorine is an electronegative because it's a non-metal. Non-metals are electronegative. Okay. So by electrostatic forces of attraction between the positive ion and the negative ion, we are forming a compound called as ionic compounds. Right now? So all these salts we are explaining about the common ionic compounds usually. Usually I am telling. Okay. Examples you take. MgSO4, AlCl3, C. Sodium chloride, magnesium sulfate, aluminium chloride, and even CaSO4, calcium sulfate, etc. Like this. See, wherever you are taking aluminium, metal, chlorine, non-metal, calcium, metal, SO4 -2, charge will be there. This is +2, -2. Magnesium, the same thing, +2, -2. Here +3, chlorine, -1. So 3 atoms are there. Here +1, -1 as usual. Okay. So how can you say? Salt is nothing but neither acidic nor basic. Neither acidic nor basic. When you take acid, you are getting reacted with acid plus base gives salt plus water. Salt plus water. So you take, for example, common base we are calling a sodium hydroxide is reacting with HCl, hydrochloric acid. Okay. So here the OH base means OH1, the common one, hydroxyl ion is there. And then H plus. This is H plus, Cl minus. This is plus minus. Okay. So this plus and this minus both are combining each other and they are forming as a water molecule. And this commonly we are calling sodium chloride. Sodium chloride. So basic definition we can give like this. Acid is reacting with the base, giving as a products salt and water. Okay. Sodium hydroxide is reacting with the hydrochloric acid. By removing of one water molecule, it is forming as a sodium chloride. This is we are calling as common salt, common table salt. So not only the sodium chloride, all the salts. That is why we are using the word neither acidic nor basic, because we are removing the hydroxyl ion and the hydrogen ion both. Even when you are removing the hydronium ion, in case of acid, this will turns into H plus, then it is forming as a H3O plus. This we are calling hydronium ion. Ion is nothing but a charged particle, just now I mentioned you. Okay, so based on this, salts we can say. Then how about the salts? Salts also we can use the indicator test. By using, we can touch the acids. Thank you so much. I hope everyone understood about this video. Next, in future classes, we are going to discuss many of the physical properties and chemical properties of the acids and bases. And then the other topics like pH, universal indicators, how can you find out whether an acid is a strong acid or a weak acid, like that. Thank you all. Thank you so much. Please subscribe my channel. My channel is Series Molecular World. Thank you all.